All right, so we have already learned how to add and subtract vectors. So in this chapter, we investigate two types of vector multiplication. The first type of vector multiplication is called the dot product, based on the notation we use for it. And so this is how it would be defined. So the dot product and its properties. Here's our first definition of the section. So the dot product of vectors u, which has components u1, u2, u3, and vector v, which has components v1, v2, v3, is given by the sum of the products of the components. So the rule that we are following then, to be super clear, is that u dotted with v says, well, go ahead and take the first components and multiply them together, u1 times v1, and then the second components and multiply them together, u2 times v2, and however many other components you have, yes, and multiply them together, so u3 times v3. However many terms are necessary based on the dimensions of the vectors, we take the products of the components and then we add them all up. So this is the formula that we arrive at. So notice that if u and v are two-dimensional vectors, we calculate the dot product in a similar fashion, right? So as sort of a general rule, however many dimensions we have, say up to the nth dimension, we are simply going to add up all of the components from 1 to n of the matching terms. So u1 times v1, u2 times v2, et cetera, to un times vn, add them all up. So when two vectors are combined under addition or subtraction, the result is a vector. When two vectors are combined using the dot product, the result is a scalar. So that's sort of an interesting result, is that when we add, we're going to get another vector. But when we compute a dot product, we get a number. So for this reason, the dot product is often called the scalar product. Right, so the dot product, also known as the scalar product. It may also be known as the inner product. These are just some common phrases that relate to this. So let's tackle an example.